So in this talk, I will be talking about exaCB, which is the framework that we developed at JSC for benchmarking applications. We initially developed it for the early access phase and also for JuBench, and I'll be talking about how that came into play. So first of all, this is the photo of the Jupyter machine at JSC, which is our exaflop machine. It's a modular data center in the sense that all of these at the bottom are containers, and at the top you can see the cooling units and from the inside. All right, so uh, so when we were getting this machine, this was going to be around 6,000 nodes, which was going to be almost 6 times more nodes and 20 times more computing power than our old machine. And so it was going to be a challenge on how we want to make our benchmark suite, which can actually procure the machine correctly. And so what we did is we looked at our um, um, compute time and what fields it was spent in, and so you could see that different uh, fields of science spend it differently. And but then the more important part is that there are a lot of different fields. So if you wanted to make something that is useful for all our users, we have to cover a lot of ground, and that is where the benchmarking suite was formed. And this is where the benchmarking suite is displayed. So you can see that we had a lot of applications here, almost 18, uh, uh, not counting the synthetic benchmarks itself, and they cover a lot of different dwarfs. Um, so this was the first kind of motivation, that we have a lot of different applications in the suite and we want to see how we can measure their performance in a automated manner. So and then once the machine started coming up, we were interested in the early access program. And so for this, in the early access program, we had a competitive early access program where we had at first 130 proposals, and we had to decide on who to select for the lighthouse applications, which are the proposals that would get the most amount of time in the early access phase, and also the time for very large scale simulations. And this is where the idea of exaCB was actually born, because we wanted to make sure that the applications were ready to actually run on the systems without the system initially being there. And then when the system came, we wanted to make sure that they can be run continuously, and also they can be run reproducibly, so that we could keep on checking the results and keep on finding out problems in the system as it is being brought up. This also was a good thing for the applications, because then the applications could also notice problems in either their code or the system, or the interaction through this kind of continuous benchmarking setup. And so what we did is that we created this framework, which I'll describe, and then we asked them to implement their benchmarks in that framework. And once they had implemented this for a small system like JEDI, which is the 48 node subset of Jupyter, then we went ahead and then later saw how they could scale. Yeah, so why we did this, I already kind of talked about it a little bit. So uh, tracking progress is what I talked about, but then a lot of applications, when they come to a new system, they also have a lot of onboarding struggles. And if you could have a very uniform way of onboarding them, then that would also solve a lot of these struggles. We could also test our software deployment. So as the system is being brought up, we discover new problems, we need new solutions, and we would like to test our solutions much quicker than you would normally do. And so what we wanted was, we wanted a way to deploy a software and run all the benchmarks, so that we can find out what is the current output. And we also wanted to use this as an opportunity to build a community around this continuous benchmarking, continuous integration setup in the PC community at JSC, so that in future when we get new applications, if they also follow the same template or the same pattern, then it becomes easier to support them as well. But then this is not without challenges, especially in a short time frame like an early access program, because you will have a lot of diverse workflows, and so you cannot make an assumption about whether they can satisfy a very strict workflow from the start right in the short time. But also you have a wide sync, so not all applications are at the same level all the time. So there are applications which start very quickly, but then there are applications which start later, and then they are at different stages of their maturity cycle on the system. And we wanted to accommodate it. Sorry, we wanted to accommodate all of them without having to change the framework a lot. We also wanted incremental reproducibility, and what I mean by this is we did not want the applications to pay upfront cost of running their benchmarks reproducibly on our system, because this involves maybe they are not ready for all the paradigms that are needed for this for our particular framework as well uh, in a short time, right? So that was to be lightweight. So maybe at first they could just run the application with a custom setup, then but we can then still run them continuously with our framework, and then slowly over time we can make them into a reproducible application for our framework. Then the third challenge, which was the fourth challenge, which was very important, was interpretability. What it means here is that we have almost 130 applications, out of which 70 applications eventually we supported. Uh, so we supported all, but then 70 we had the final reproducibility results, and uh, all of them will have their results in certain form. All of them will have their results with a certain figure of merit which is relevant to their domain. But then when as a system administrator you are looking at this, or as a technological explorer, then you want some sort of an uniformity in the report that you see, so that you can quickly see how many applications are actually doing worse than you thought they would, and what kind of problems do they indicate. So this was the challenge. So we started with these challenges, which are mostly of scale rather than of scientific domain. And then the final challenge was kind of asynchronous progression. So we wanted to put all of this in the CI, because then we could do all of this asynchronously without having to uh, have meetings with everyone. We could do this in GitLab issues and then use the GitLab development process for all of this, or GitHub if you wanted, but in this case we use GitLab. And so for this we had this workflow where we use Jube here, but then technically we could support any framework. We could support Ramble, we could support Reframe, but then we did have expertise of Jube in-house at this point, and we did need some quick iteration cycles. So the first class support was for Jube, and then other was more on demand. So what we asked the applications to do is that they would write their benchmarks in Jube, but this doesn't have to be that they build their benchmarks and run it in the starting. They could just have an executable somewhere on the system and run it in Jube, and then slowly over time they put their build instructions in it and then put other stuff in it. And then we wanted a declarative framework for running this in the CI, which I'll come to later. So then it went to the Yakama runners, which were developed in the exaCB project, and then through the HPC systems into a recording. So all of this was done through CI in a uniform manner. And let me show you how this worked. So so this is a template for how the CI would work for running the simulation itself. So we use GitLab CI/CD components here, uh, where you can include this component and then pass it some inputs, and then it will essentially run what is equivalent of a juke run with some inputs and the juke file that you have. And the inputs were kind of standardized in the early access program because we wanted to keep things simple, but this does not have to be always the case in future. Already now we are looking at now expanding it slowly. So the important thing is the variants here. So we asked the applications to implement certain variants, which are in this case strong tiny, which is a tiny version of a strong scaling benchmark. And then you could have weak benchmarks, and then you could have single node benchmarks and complete system benchmarks. And then the rest of the things are kind of very bureaucratic in the way of which machine you want to run it on and what budget do you want to use. And this was important because you would always have users running their own budget, and then sometimes the sysadmins would need to reproduce this result, so they would have to put their own budget in it. So right now, this is in the GitLab CI string, but then people could put it as an environment variable in the CI runners, and this could be modified by the sysadmins when they are triggering a certain run, and then this would run on their budgets. And then, of course, with juke file to implement to run. So apart from this, we had facility to run fixtures, either set up or tear down. So they could run some steps before the benchmark runs and then after the benchmark runs to generate the data and then delete it or something similar. So all the applications would then include this in the CI/CD file, and then this way it was very easy for us to audit if all of them are running kind of the same benchmarks, or if all of them are running strong tiny at this point, or how many of them are running strong big, which is a 900 node benchmark, and we could figure out things like this. And this is an example juke file, but I think I will skip this for now. And then we had the report generation. So in the starting, we started out with a very simple report generation where the users could include another GitLab CI/CD component, which is now called here, and they could now put a GitLab CI pipeline from which they want to get the data. So in the last template, we ran the simulations or the benchmarks, and in this one, we can take the CI/CD pipeline from where you want the data, and then you can run it through a selector to actually pick the correct job. And then it would automatically plot a result and put it in a GitLab repository as well. So one thing I forgot to mention was that in this template, it would run the simulation, get this kind of a data CSV format, and put it in either in a repository or in an S3 storage, which is controlled by the repository itself. So the data then stays in the repository, and you can maintain the privacy of the applications in the initial stages. And you don't have to do anything fancy at this point. So then this CI/CD again now fetches the data from the same repository. So it's again running inside the repository, and then it will generate this kind of a plot you see on the right, where we are now comparing all the three different machines, the Eureka, the Juelich, and the Jedi at our place. And in this particular case, we demanded in a way that all applications report in terms of runtime. So which is not the best measure for scientific domains, but then if you convert your domain specific figure of merit to a common figure of merit across applications, then it becomes easy for the sysadmins and even the applications to compare their results with other application results and then figure out if things are matching or not. So this was a very simple generation. Then we also had another kind of a report generation. So technically you could do any kind of report generation because then now we had the data already in the repository, and this was for the large scaling plot where we did a mix of weak and strong scaling. And we use this again to do time series. So you could see, so we could just put a new component and then we could decide what we want to plot. So here then we also plotted, for example, different figures of merit. So this is a stream benchmark and we plotted all this benchmarks in them, the subcomponents. But also now you can see that we have a much more complex pipeline selector now. So technically we could do more complex pipeline selection rather than specifying manually which pipelines to use. And this, for example, gets us into an area where now we can use only the pipelines which have succeeded of all the pipelines in the past 1 year, something. Of course, the applications could also use this and then they would get all this data generated for them automatically in the repositories. Then a very nice use case that we had of this was energy measurements. So this was not initially something that we thought about when designing the framework, at least in the concrete manner, even though we did think about it in an abstract manner. But what we realized is that we could use this and just change the component here, and this component would do some kind of an injection uh, into how Jube is run. And this allows us to then insert energy measurement parameters. And now here it comes how applications are prepared. So for a lot of applications, we could just do power measurement throughout the life cycle of an application. But then some applications which are instrumented correctly in a way where they tell us what kind of time profile is actually the compute profile. So what kind of time interval is actually the compute intensive part or the relevant compute intensive part. Then this can be marked as these black lines you see here. And then we can measure that energy, sorry, the power only in that particular area. And so we could do this and then without changing the code of the applications or the benchmarks, we could inject this and get energy measurements for all the applications and then more targeted relevant energy measurements for some applications which are instrumented well. So we did this and so then we could do this energy measurement for different kinds of applications here, HPL, MP-Track, SOMA, and we could figure out different characteristics for them. One of the advantages of this was also that we could run frequency measurements. So we could change the frequency of the GPU without having to change the code and then insert all of this. And now what we are working on with this data is that we are now exposing this data also to LLView, which I also mentioned in the last talk a little bit, where we have all this data and we now can correlate this with the energy measurement or other utilization measurements that we have in LLView. So now we are running, we have integrated this framework now in integrate this with LLView, and now we can see this result. So these are kind of the synthetic benchmarks that we are running. We are also running other benchmarks, but I am only showing the synthetic ones for now. And this allows us to kind of show us and all the users who are using LLView if the application is working or not working. And if something goes wrong, they can notice it. So it was kind of a long journey till now, but it is still, I would say it is still in the initial phases, even so. So because we still have a lot of work to do here, but we still learned quite a bit of lessons here. So when we were doing this early access program across all these applications, we realized that the CI/CD components are kind of useful for us, but the CI/CD steps components or GitHub actions are the equivalent in GitHub. If we can provide them to users, it's easy for users to use them, but this is kind of known. And then what our system allows is kind of instrumentation on demand, even without changing the benchmark files. And we have machines consumable artifacts. We realize that the data formats that are generated are kind of much more important than the actual tools, because technically this could have been done with any tool and we would get the same results. But then, so we could get reframe, we could get ramble. And the importance of having this in the CI like this is the upstream integration advantages. So for example, someone who has a GitLab repository can now integrate this into their own code as well, and then have a CI benchmark running on our systems in their CI, which they can either use or not use. Yeah, so this is kind of it. And we are kind of still developing it more now. We are uh, as I said in the starting, we had Jupyter benchmark suite, and now we are running them. We are running exaCB for at least a subsection of that Jupyter benchmark suite, and we are planning to add more applications to it. But apart from that, in JUREAP itself, we were able to integrate like up to 70 applications in a very short time frame of something like 3 months. Even though not all of them were perfect in the starting and slowly matured over time. And the final thing I wanted to say is that the CI/CD thing allows you to kind of easily share your workflows, because if something goes wrong, you can just point people to the pipeline, where things go wrong, and then essentially you look at this as you would do with any software development project and figure it out through the commits and the merge request and all of this. So this was a big help as well. So that's it. Thank you for listening, and I'm open to any questions or comments.
Any questions? There you go.
Hello. So I noticed you did a lot of, I see all your work about collecting the data and collecting the benchmarks, and that looks really cool. I'm just sort of curious what you do with the data after you have it. So I like your plots and how it's easy to see what the performance is, but like, do you run anomaly detection, or do you run like any of these continuous monitoring things to try and like identify when there are issues in a more automated way that doesn't require you to go be looking at graphs all day, basically?
Yes, thanks. Yeah, so in the initial part, when we were developing this framework, we did not have a sophisticated way of doing this. But now we are slowly doing that, yes. Especially in the LL view, we are starting out with some algorithms which can do this. One of the algorithms is, sorry, I forget the names, but we are starting out with some of them now, yeah. But I guess your question was what we would do with all this data, right? Apart from this.
Yeah, what do you have an answer to that part?
Yeah, so what we did is we did a lot of comparative benchmarks. So for example, we had all these applications, and then we had an idea that our system should be, per node maybe should be twice as fast as the old system, like, because the old system was A100 and this was TH200, and then we could kind of see if that actually holds up when we do the collection of all these benchmarks, right? So because we have all of this in the CI, we could create a meta repository which could trigger all these CIs, and we could select which ones to run, and all the data that we have. So we could pull all on this data through CI and then run all this kind of, how do you call this, collection of benchmarks results. I forget a good name for this, but yeah.
Sweet.
We do this now, yeah.
Yes, I have a question. Have you closed the circle with any of these 70 applications that are in the suite? Like, have they actually improved the application, and are they continuously updated over time, or are they just kind of tossed over the fence and put into the benchmark suite? This is something that we deal with.
Yes, this is also something that we wanted to address, and to be honest, we are not completely successful with all 70, but I think we are successful with around 30 of them.
That's actually really good.
Yeah.
I was not expecting 70 or even 10, so 35 is great.